Right. This video is going to be a review of rational equations. Yesterday we did rational expressions. They're basically fractional expressions without equal signs, but now you'll have equal signs in the expression. Okay, so again, as I told you before, once you have an equal sign, you have to solve for the letter x. Now there's a couple different methods of doing this. Um, I'm going to show you both ways and then show you what's preferred. Uh, so you see a bunch of, you see basically three fractions here. Again, the number 2 is written quite big, but you want to consider that as a fraction. So you can rewrite this as x over 4 equals 2 over 1 plus x minus 3 over 3. And again, for clarification purposes, you do want to put a parenthesis around any binomial or trinomial on top of a fraction bar or on the bottom, just to indicate that that fraction, that parenthesis represents one single number. Now, I keep saying the word traditional, but one common way of doing this is to just get common denominators of all three fractions and then start, doing your thing. So between 4, 1, and 3, the common denominator happens to be 12. So if you write all of these with 12 on the bottom, right, and you want to create equivalent fractions, for here you have to multiply the top and bottom by 3. So this will become 3x over 12, and you can double check by going reverse order by reducing 3 and 12. It'll go right back to x over 4. For this one, you'll have to multiply 12 top and bottom, so you'll have 24. And for this one, you'll have to multiply 4. So this will be 4 parenthesis x minus 3. Now again, if you're confused about what I just did, I basically skipped a step. Okay, I'll do it this way. I'll erase all of this and rewrite it again and write it like this. I'll multiply this one with 3 over 3 so that it'll become 12 on the bottom. 3 over 3, again, as I told you before, it's like multiplying by the number 1. Here you're multiplying this by 12 over 12 because we again want 12 as a denominator. And for the final fraction, we want 4 over 4 so that 4 times 3 becomes 12 on the denominator again. All right, you multiply everything out and you get 3x over 12 equals 24 over 12 plus 4 parenthesis x minus 3 over 12. Now, once you have common denominators, especially on the right side of the equation, you want to combine two fractions into one by keeping the denominator the same and just adding the top. 24 plus 4 parenthesis x minus 3. And then you do some more simplifying. On the numerator right here, you can distribute the 4. And so this will be 24 plus 4x minus 12. 3x over 12. Now at this moment, there's a couple things you can do. Realize that because the two fractions on the left side and the right side are to be equal, and because their denominators are equal, you can automatically assume that the numerator should be equal to each other. Oh, let me make that a little bit more simpler. We're writing this as 24 minus 12 is just 12, so this will be 12 plus 4x and 3x over 12. So again, as I told you before, mathematically, if the two equations or two fractions are set equal to each other and the denominators are exactly the same, the numerators have to be the same. So you can automatically write 3x equals 12 plus 4x. Now, if that doesn't make sense, then let's take a step back and try this. We're going to multiply both sides by 12 to get rid of the denominator. Okay? And cancel, 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 and then you're left with, again, 3x equals 12 plus 4x, and you keep solving. You subtract 3 to the right side, bring the 12 to the left, you'll have negative 12 equals x, and that is your final answer. Now again, as I zoom out, it's quite long. Is there another way of doing this? Yes. So the reason I wanted to show you this procedure is because there are some problems where you will actually have to find the common denominator and just take the longer route, but there's always going to be a different, shorter way, okay? All right, so what's another way of doing this? Well, let's rewrite this problem again. X over 4 equals 2 plus parenthesis x minus 3 over 3, and we're going to put a 1 underneath the 2. Now what you can do here is immediately multiply both sides by the common denominator. Now again, you might be asking, well, how did you know you can do that? Well, it is a technique, but the idea is basically this. Whenever you have an equal sign, and this is just a random, expression, 4x equals, let's say, 17. When you have an equal sign, there are 4 properties of math called the addition property, subtraction property, multiplication property, and the division property. And what that means is you can do any 4 of those operations as long as you do to both sides. You can technically do whatever you want. So, let's just say randomly, I just wanted to multiply both sides by what? 3. Can I do that? Yes. And the question is, why is that okay? Well, because it's still equal, right? 4x is equal to 17. It's already balanced. Multiplying both sides by 3, it's still going to maintain its balance. You're on the right track. The real question is, so should you do that? And the answer obviously is no. What you want to do in this case is obviously try to get rid of the 4 so that x is isolated. And we do that, again, by multiplying both sides by 1/4. I know some teachers will say divide both sides by 4. You cancel those 2 out, and then you have x equals 17 over 4. You can add to both sides. You can subtract to both sides. Here, you have an equation, and we're going to simply multiply both sides, and you want to put a big bracket because that whole right side with 2 fractions represents one side of the equation. This represents the other one side, and both sides are to be exactly the same. You have to treat them the same. So I'm going to multiply both sides by the number 12, which happens to be the common denominator of these 3 numbers, 4, 1, and 3. Now you might be asking, well, why? Well, watch what happens. When you take the common denominator and you multiply both sides with it, the denominator cancels out. Here, the 4 and the 12 cancels out. This will become 1. This will become 3. What's left? 3 times x is simply 3 what? 3x. What about the right side? Now remember, we're distributing the 12. So 12 is given to this fraction. 2 over 1 times 12, well, that's just 24. And here, 12 given to this fraction. And what you can do is before you multiply that in, you can reduce. And by the way, this is actually 12 over 1. Same thing on this side, 12 over 1. Any number you multiply is basically a fraction. So when you're multiplying fractions and you have a number here, 3 and 12, and you can reduce them, you can go ahead. This cancels out. This becomes 4. So now you have 4 multiplied to this expression right here. So we're going to write 4 parenthesis x minus 3. And notice this line is this line right over here without having to go through all of this. Okay, definitely shorter, definitely much better and preferred. And then you just do your basic math. 24 plus 4x minus 12. And you simplify these two. These become 12. And I'm going to subtract 3 to the right and subtract 12 to the left. This will become negative 12 equals x. And there is our final what? Answer. Okay, there you go. So we're going to use this method or this procedure, but now you know why. Let's see, I think I picked another one here. Yep. All right. Now, the difference between this problem and the one that we're going to see here is that now you have variables on the denominator. Whenever you have denominators with a variable, you always start with the excluded value. Okay? Now, to find the excluded value, you want everything on the denominator to be factored. So again, x minus 1 is itself a factor, 2 is a factor, but here you realize you can pull the 2 out. So you're going to rewrite this as 2 parenthesis x minus 1. So this is in its factored form. We're going to look at each term and ask ourselves, what is the excluded value? Well, here we do not want x to ever become positive 1, because if you plug that in, it'll turn to 0, and we never want to have a 0 on the denominator. Here, turns out it's the same thing. You put 1 right here, it turns into 0. So this right here is the excluded value. You don't have to worry about 2. There's no variable attached to it. It's just 2. It will never become a 0 in the denominator. All right, so I'm going to rewrite this in its factored form, and then do the same thing as I did in the previous problem. Multiply through by the common denominator. So we have 3 over 2 parentheses x minus 1 plus 1 over 2 equals 2 over parentheses x minus 1. And you look at those 3 denominators and you ask, what's your common denominator? Well, you can see that it's basically this guy. 2 times this. This one, he needs a 2 and x minus 1. This one needs an extra 2. Because our goal is to have all 3 fractions with the exact same factors in their denominator. So this will be the common denominator for all of them. So what I'm going to do is take the left side, put a bracket, and the right side, put a bracket, and multiply both sides with the same common denominator. 2 parentheses x minus 1, 2 parentheses x minus 1. All right, so let's start distributing. This times this fraction. Again, you're technically multiplying this fraction to that fraction. The numerator on this one looks just like the one on the bottom of the right. When they're the same, you can cancel it, you can cancel it out. Now, I'm not going to cancel, well, here, fine. I'll just cancel it out for this one. So what's left here is the number 3. So you just bring it down. Now, to distribute this back to that, I'm going to take off the streak. And again, we're going to multiply this whole thing to 1/2. What's common between them? 2 up here, 2 down here. You can cancel those 2 out. Oops, I just deleted that by accident. 2 and 2. So what you have left here is a 1. 1 times whatever's left here is x minus 1. So x minus 1, put that right there, equals. Now on the right, you have more to cancel out. You have x minus 1 and what? X minus 1, what's left? 2 times 2, which is what? 4. And there you go. Very simple. 3 plus x minus 1 equals 4. Now, one question you might have is, how do I know if I can take the parentheses off? Well, you first check the upper right to see if the exponent is just a 1. And if there's no number in the front to multiply into the parentheses. If you have here's just a different scenario. If you have a negative with a parenthesis x plus 1, then you have to distribute the negative sign in there. Then the parenthesis will come off. Okay? So as long as there's no number up here except the 1 and just a positive symbol, you can remove the parenthesis, equaling 4, and 3 minus 1 is 2, x plus 2 equals 4, and then subtract 2 to both sides, so x is equal to 2. Are we done? Not quite. What we have to do is double check that this answer is allowable. We look at what x's are excluded. As long as you don't get a 1, we're okay. So 2 is fine, so check. This is our answer for this problem. Okay, I'll do a couple more. Here again, the first thing we realize is there are x's on the denominator. Anytime you see that, immediately you go for the excluded value first. Here, x equals 3 is excluded, so we never want x to ever equal 3. We never want x to ever equal -1. Here, we realize to find which x's will turn this into 0, we have to factor it. So I'm going to put 2 parentheses here, and I'm going to put 2 x's right here, because x times x is equal to x squared. Now to do this, all you have to do is look at the last number, 3. What 2 numbers multiplying to 3? Well, in this case, it's just 1 times 3. Turns out that 1 and 3 can add up to -2. How? If 3 was a negative and 1 was a what? Positive. So we put -3, +1. And again, the order in which you write this, it doesn't matter. You could actually write it like this, x plus 1 and x minus what? 3. It's the same thing. So, all right, so in this case, x cannot equal +3 or negative what? 1. And it turns out it's the same thing here. Oh, look at that. You have x minus 3 here, which is basically that factor, and you have an x plus 1. So these two denominators require, well, this guy needs x plus 1, x plus 1 here needs an extra x minus 3, and everyone will have the same denominator. But we're not going to write it out with common denominators. We're just going to find the common denominator and then multiply it all the way what? All the way through, and bada bing, bada bang, all the denominators will somehow just vanish, right? Okay, so let me let's rewrite this. X minus 3 minus 2 over x plus 1 equals 8 over x minus 3 x plus 1. All right, we know what the common denominator is, so we're going to multiply both sides by that common denominator, x minus 3x plus 1, and here x minus 3x plus 1. And again, you're basically multiplying, you know, like a fraction, this over 1 and this over what? Over 1. Okay, so I'm gonna start with the right. It's just easier. So notice that the denominators are exactly the same with the numerator on the right side. So all of these would simply cancel out. Cancel, 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 cancel. And you're left with the number 8. All right. Now here, again, you have a bracket or a set of numbers with a factor on the outside. You're going to distribute this in. This times that. The x minus 3's will cancel out. You're left with simply x plus 1. And again, you can leave the parentheses on for right now. And then you go to the next term. This times negative 2. There's an x plus 1 on the bottom here. That will cancel out with this guy. So I'll do that with a blue color. Cancel, cancel. And you're left with x minus 3 being multiplied to 2. But always remember that there's a negative sign here. And it's really, really important. Do not try to multiply all of this out in your head and then write it down. Take the extra step, extra precaution, so you don't get this thing wrong during the test. You're gonna write this as negative 2, okay? Parenthesis, this guy right over here, x minus 3. Now, if you do it this way, you're not going to make the mistake of forgetting to distribute a negative 2. I've seen students, they try to do this in their head, and they write it out like this. Negative 2x plus what? I'm sorry, negative 2x minus 6, because there's a negative right here. Without realizing that this negative 2 has to be distributed to negative 3, which we see it right here. Negative 2 times negative 3 turns this into a what? Positive 3. Can I remove the parentheses? Yes. So x plus 1. And it equals 8. And again, very simple. X minus 2x will become negative x. 1 plus 6 will become 7. And then you subtract 7 to both sides. Or positive 1, sorry. And then you you multiply or divide both sides by a negative number. And you get this answer. Are we done? No, because we have to check if negative 1 is allowable. What's our excluded value? Dun, dun, dun. There is an excluded value right here, meaning we do not want negative 1. We end up getting negative 1. So what's our answer? No solution. Okay? No solution. That's when you say no solution. So if you get an answer and one of them happens to be an answer that's excluded, you say no solution. Okay? All right, so let's do, how many more do I have here? I think this is the last one. I know yesterday I tried to do all 3. I just ran out of time because it took so long. But this will be our last one for tonight. Okay, so step number 1, excluded values. This is x equals, or x cannot equal negative 2. X cannot equal 4. And again, here we have to factor this out in order to find our excluded value. So we put x and x there because, again, x and x multiplied is x squared. The last 2 numbers here have to multiply into negative 8, but those 2 numbers have to add up to negative 2. What are the factors of 8? We have 1 times 8, or we have 4 times 2. Which one of those pairs can be used to add up to negative 2? Obviously, the 4 and 2. If 4 is a negative and 2 is a positive, excuse me, then negative 4 plus 2 will become negative 2. Negative 4 times 2 will become negative 8. There it is. All right, so here we say, oh yeah, same thing, x cannot equal 4. Here, x cannot equal negative what? negative 2. So we see that everything is basically a factors of negative 4, x minus 4, and x plus 2. Let's rewrite this so that we can see the common denominator visibly. X minus 4, 30 over x minus 4, x plus 2. And the common denominator is basically x minus 4, x plus 2. So we're going to multiply both sides by that. And here we go. X minus 4, x plus 2, x minus 4. All right. So again, start with the right. It's just easier. Cancel, cancel. And all you're left with is the number 30. Left side, you should be getting better at this. This times that. The x plus 2 cancels out. You're left with this and the 4. So this will be basically 4 parentheses x minus 4 plus this times that. The x minus 4s will cancel out. And what's left? X plus 2 being multiplied to 2. So this will become 2 parentheses x plus 2. And again, I'm not going to distribute this out in my head. I'm just going to wait till the next line. Okay, so now let's distribute everything out. 4x minus 16 plus 2x plus 4 equals what? 30. Combine like terms. 4x and 2x becomes 2x. Sorry, 6x. And negative 16 plus 4 will become negative 12. And you add 12 to both sides. 30 plus 12 becomes 42. And x equals 7. Is this a permissible answer? And we see that, yep, 7 is not excluded. So here it is. All right. Study well. I hope you do well on the next exam. This is your rational equations. Have a good night.